and welcome to Chemical Cooking with Callie, Katie, and Carly.
Today we will learn all about the chemistry in macaroni and cheese, popcorn, and even ice water.
Our main parts will include convection, endothermic reactions, physical change, energy, radiation, fuel, and exothermic reactions.
If you still want to learn more about these after the show, you can read more about it in activities 1, 3, 4, and 5. Now, on to the show.
Our first dish will be macaroni and cheese.
To begin, you'll need a pot, a liquid measuring cup, and a box of macaroni and cheese.
Milliliters would be ideal, but we know that 1 cup is the same as 237 milliliters.
First, we need to add 6 cups of water and bring it to a boil. We already added our 6 cups of water.
As the water boils, it undergoes a physical change.
Once the water reaches 93 degrees Celsius, it goes through a phase change and becomes steam.
However, the water itself will never get hotter than the boiling point, even though you are still adding heat energy because all the extra energy is being used to change the state of the water from liquid to gas.
While we wait, I might mention that this is an endothermic reaction.
As you heat the macaroni, it adds energy, which means that the macaroni ends up with more energy than it started with.
Well, it looks like it's ready to add the noodles. Look at that physical change.
As we are cooking the noodles, it uses convection to heat them.
Because we cook them in water, a liquid, then it's using convection to transfer the heat to the noodles. Now we're going to be comparing 2 different ways to cook popcorn.
We will be cooking it in the microwave and on the stove. We will need popcorn kernels, a pan, oil, and a bag of microwave popcorn.
We are going to be comparing how much energy is used to cook the popcorn.
To do this, we'll take 2 tablespoons of oil at 23 degrees Celsius and heat it for 30 seconds.
This will show us the rate that the microwave heats the oil.
We will then cook the popcorn on the stove and see what temperature the popcorn starts popping at.
Cooking! It looks like it raised to 30 degrees Celsius. I think it might actually work. It's working! It's really hot. It's just sticking in my
Take off the lid.
It looks like it popped at 40 degrees Celsius.
We did some research and found that the oven uses 10 to the 4th joules per second.
Oh, by the way, I should mention that that was also the microwave cooked using radiation.
The heat energy travels through space.
Which is radiation. So, we found out that the microwave uses 576 joules per second.
This shows that the microwave is more energy efficient.
That's okay.
I understand.
Okay. We also did some research and found that the stove used 7 grams of fuel to cook our popcorn.
Today was so much fun.
Let's cool down with a nice ice water.
As we can show for our ice water experiment, our regular room temperature glass is about, what is it in Celsius? 23 degrees Celsius. And when we added ice, it is about 16 degrees Celsius. When it cools down, it is taking energy away from it.
That's an exothermic reaction.
In conclusion, when cooking macaroni, the boiling water created an endothermic reaction, causing a physical change to take place with the macaroni noodles.
You guys need to eat stuff too.
When we popped the popcorn, it took more fuel and energy to cook it on the stovetop compared to in the microwave where it used radiation instead of conduction.
And that's our show.
Okay.